video, we're going to take a look at how to perform partial fraction decomposition when we have a fraction with linear factors in the denominator. So the first thing you want to do is take a look at something that has this form. It has a function on the top, and in the denominator, you have x minus a times x minus b. All right, so these are linear factors in the denominator. Once you see that it's in this format, and it may require that you factored the denominator to get here, you'll be able to write it in its decomposed form. And that's going to be a over the first factor plus b over the second factor. Once we have that, we'll be able to combine the fractions on the right-hand side by finding their least common denominator. Then we'll solve for the values of a and b and substitute them into that decomposed form for our final answer. This helps a lot when you take a look at an example, such as 4x plus 5 over x plus 2 times x minus 1. Remember, we want to rewrite this in decomposed form. That means a over x plus 2 plus a b over x minus 1. Notice those x plus 2 and x minus 1 factors come from the original denominator. Now we need to combine the fractions on the right-hand side. In order to do that, we need to recognize that the least common denominator, or LCD, is x plus 2 times x minus 1. The first fraction only has x plus 2, so we need to multiply it by x minus 1 on top and bottom. Similarly, we need to multiply the second fraction by x plus 2 on top and bottom. When we do that, we can distribute the a in the first fraction and the b in the second fraction. That gives us ax minus a and bx plus 2b. Now we want to go ahead and combine these into a single fraction. When I do that, and I notice that ax and bx are really a plus b times x, and minus a and plus 2b are also like terms because they don't have an x. So I write them as plus negative a plus 2b. It looks like what you see right here. Now, that seems a little complicated, but don't worry, it's not so bad, because what we're really doing here is we're saying the coefficients of x equal to one another and the constants equal to one another. So what do I mean by that? Well, remember, our original fraction was 4x plus 5 over x plus 2 times x minus 1. And since that's equal to this expression we've created on the right-hand side, we know what's in front of the x on the left has to equal what's in front of the x on the right. So 4 has to equal a plus b. Similarly, again, the constants have to equal one another. So since there's a plus 5 on the left-hand side, the minus a plus 2b also has to equal 5. So now I have two equations that have my a and my b in them. So I just need to solve this system of equations. Now, the way this one is set up, it's really easy to solve using elimination, which is also known as the addition method, because what you're going to do is you're going to add the two equations together, and it's going to eliminate one of our variables. So I do 4 plus 5 is 9, a plus negative a cancels, and b plus 2b is 3b. Now it's really easy to solve for b. I'm going to divide both sides by 3 to see that b equals 3. Now I just need to find my a value. So what I'm going to do is I'm going to take that b equals 3 and I'm going to substitute it into the first equation. So instead of 4 equals a plus b, I'm going to have 4 equals a plus 3. This is pretty easy to solve for a, thankfully. I'm just going to subtract 3 from both sides, and I find that a equals 1. Well, now that I know my a and my b value, I'm going to go back to that decomposed form that I'd written out before. But now I'm going to replace the a with 1 and the b with 3. So now I can see that 4x plus 5 over x plus 2 times x minus 1 can be decomposed into the fraction 1 over x plus 2 plus 3 over x minus 1. And that is how you work with partial fraction decomposition.